Welcome back to my new session of data structure. Stacks is a linear data structure. Here there is no element into the stack. I can call it as stack is empty. And here I am going to add an element, and we have some operations on stack. Very important question for 5 marks. Explain the operations on stack. So first operation is stack of. Welcome back to my new session of data structure. I am Shweta, Computer Science faculty, Vidhyaashram College, Mysuru. In my last session, I have discussed about the sorting technique. Sorting means arrangement of elements either in ascending order or descending order. So I have discussed insertion, sort, and also I have discussed the two-dimensional array. A two-dimensional array is a collection of elements. Each element is having two subscript values. Each element is having two pair of indices, so we can call it as a two-dimensional array. Example, A of 6 and 5. A of 6 and 5 means it consists of two subscript value. So two-dimensional array is a collection of elements having two subscript values. And also I have discussed the memory representation of two-dimensional array. So we can find the row major order and column major order. So using m cross n order of matrix, we can find the memory representation of two-dimensional array. So today I am going to discuss about the new topic, very interesting topic called stacks. So what do you mean by stacks? Stacks is a linear data structure. All the elements are arranged in a sequential order. Stack is a linear data structure. Elements are arranged in a sequential order. And in stack, we can arrange the elements in some proper order. And a stack is an ordered collection of items or elements where the inserting an element and deleting an element takes place at the same end, called top of the stack. Where the insertion and deletion takes place at the same end, that is called as top. This end is called as the top of the stack. So, stack is a linear data structure where the addition of new elements and the deletion of an existing element takes place only at the same end, called top of the stack. So here the index value starts from 0 to max minus 1. 0 to max minus 1. 0, 1, 2, 3 up to maximum value minus 1. So stack is a linear data structure where addition of new items and deletion of an existing element takes place only at the same end, called top of the stack. And the end opposite to top is known as base. The end opposite to top is known as base. So this is called as stacks. Stacks are sometimes known as LIFO. Stack is a LIFO mechanism. So what do you mean by LIFO? Last in, first out mechanism. Stack is a last in, first out mechanism. Why it is following the last in, first out mechanism? Because the element which is inserted last must be deleted first. The element which is inserted last must be deleted first. Example, 1, 2, 3, 4. Here have 4 number of elements. The element which is inserted last must be deleted first. So that is what we can call it as stack is a LIFO mechanism. Stack is called as LIFO, last in, first out mechanism. The element which you are inserted last must be deleted first. This is called as last in, first out mechanism. Example, we have so many daily life examples for stack. The best example is the arrangements of coins. The element which you are inserted last, that has to removed first. This is called as last in, first out mechanism. And number of plates in cafeteria and arrangements of books, wearing a bangle. These are the examples for last in, first out mechanism. Stack is an ordered collection of items where the insertion of a new elements and the deletion of new elements takes place only at the same end, called top of the stack. So, stack is a linear data structure, and stack can perform two main operations called as push and pop. Push and pop. So, what do you mean by push? Push means inserting an element into the stack, and pop means deleting an item from the stack. Push means inserting an element, adding an element, and pop means deleting an element, removing an element from the stack. So, example, this is our stack. So, inserting an element means we are pushing the elements, and deletion of elements means we are popping the existing elements. We are popping the elements, called as removal of elements. Pushing means adding an element into the stack. Pop means removal of an element from the stack. So, stack can perform two main basic operations called push and pop. And next we will see the representation of stacks. The items into the stack are stored in a sequential order from the first location of the memory block. Example, so here I am adding an element. So here there is no element into the stack. This is one stack. Here there is no element into this stack. So we can call it as empty stack. This is empty stack. There is no element into this stack. We can call it as empty stack. If stack is empty, we can call top is equal to minus 1. Stack is empty, so we can call top is equal to minus 1. This is one empty stack, and in this empty stack I am going to add an element. Example A. This is called as pushing an element to the stack. This is stack element. So here I am placing one element into the stack, that is called as top is equal to top plus 1. I am going to add an element into the empty stack. So I can add an element A, B, C. Here I have added two elements. The index value is 0, 1, 2 up to max minus 1. So this is the representation of stack. Here there is no element into the stack. I can call it as stack is empty. And here I am going to add an element. Here I have added 3 elements, 3 items, that is top is equal to top plus 1. Here I have added 3 elements, that is A, B, C. Index value is 0, 1, 2. If you want to add the next element to this stack, if you want to add the next element called D into this stack, is this possible to add an element into this stack? No, it is not possible, because there is no space for adding the next element into the stack. Then we can call it as stack is overflow. Overflow means there is no space for adding a new element into the stack. This is called overflow. Stack is overflow. There is no extra space for adding this element D. This stack is called as stack overflow condition. So here I have pushed the element. Pushing means adding an element into the stack. Here I have pushing the element. Here stack is overflow. There is no space for adding the next element. And what is the meaning of pop? Pop means here I am going to remove one item into the stack. I am going to remove one item into the stack, that is popping an element. This is called as removing an element from the stack. This is popping an element from the stack. So here we have 3 elements, that is A, B, C. Top of the stack is, this is called as top of the stack. Top of the stack is 2. Here I am going to removing an element from the stack, that is called as popping the element, that is top is equal to top minus 1. Top minus 1 means removing the element from the stack. That is called as popping an element. Pop means removal of element. Example, I am going to remove all the elements. First I will remove C, that is the top of the element, and next I will remove B, that is the next element, and next I will remove the element called last element is A. So this is the concept called popping an element from the stack. After this removal of an element, our stack will become empty. After removing the elements called A, B, C, our stack will become an empty, right? So this we can call it as stack is underflow. There is no item for removing. There is no item for removing. So we can call it as stack is underflow. This is stack is underflow condition. There is no element for stack is underflow means there is no element for removing. In representation of stack, first we need to check the stack is full or not, or it is empty. Then we can add the element into the stack, and after adding the element, if you want to delete an item from the stack, you can pop the element from the stack. After popping all the elements, stack will become an empty. So again, if you want to delete an item from the stack, there is no item for deleting, then we can call it as it is underflow condition. If there is no element for deleting item from the stack, then we can call it as stack is underflow condition. And stack is overflow means there is no space for adding the new element means condition is overflow. Overflow condition and underflow condition. First we have to check the condition is overflow or underflow. And stack is empty means we can call top is equal to max stack. Here the stack is empty, there is no element in this stack, so we can call top is equal to max stacks. You can see the picture. Empty stack means there is no element in this stack, and if you want to add the new element into the stack, we can use the operation called push. And if you want to add an element into the stack, that operation is push. Again I am pushing one more element. Now stack becomes 1, 2, 3. Stack item is 1, 2, 3. Now stack is full. Stack is full means stack is overflow. Condition is overflow. Top is equal to max stacks indicates that stack is full. The stack is full. Called as top is equal to max stacks. And if you want to delete an item from the stack, you can use that pop operation. So from the top of the stack, you can delete all the items called 3, 2, 1. So here top of the stack is 3. Top of the stack is 3. And if you want to delete that items, so you can use that pop operation. And after popping the elements, we will get the empty stack, that is stack is underflow. There is no element for deleting. This condition is called as underflow condition. There is no item in this stack means top is equal to null. There is no item for deleting. That indicates top is equal to null indicates the stack is empty. Stack is empty means there is no element in the stack. This is an empty stack. Here I am going to push an item. Here I am going to push an item. Here also I am pushing one more item, and here I am removing all the items. After removing, the condition will become underflow. There is no item for deleting an element. So this is called as the representation of stack. And we have some operations on stack. Very important question for 5 marks. Explain the operations on stack. So first operation is stack off. Stack off means it creates a new stack, that is empty stack. New stack means we are going to adding an element. Before that, the stack will become an empty stack. And push item. Push item is adding an item, adding an element into the stack. Here I am going to add an element, that is called as push operation. And pop. Pop means deleting an item. Here I am going to pop an item. And we have peek. Peak means it returns the top item. It returns the top item from the stack but does not remove it. Popping means it removes an element, but peak means it returns the highest value in the top but it does not remove any element. So pop means it removes the items from the stack. Peak means it returns the topmost element but it does not remove the element. So peak and pop. And is empty. Is empty means it tests whether the stack is empty or not. It tests whether the stack is empty or not. And size of. Size of means it returns the number of items on the stack. Example 2, 3, 4. It returns size of means it returns the number of items on the stack. These are the main operations performing on stacks. So first we'll see the main operations of stack called push operation. Push means adding an element, inserting an element into the stack. Push means the process of adding a new element into the stack. Here you can observe 0 is my bottom value. Base value starts from 0, 1, 2 and 3. 3 is my top value. Once I push the element, so 4 will become the topmost value. This is called as pushing an element into the stack. Here totally we have 0, 1, 2, 3. After pushing an item, 4 will become the topmost element. So totally we have 4, 3, 2, 1, 0, 5 elements we will get. After pushing the item, so totally we will get 5 items in the stack. So the new element is added at the topmost position of the stack. Here new element is added from the topmost position. Topmost position is this is the topmost position. New element is added from the topmost position to the stack. This operation is called as push operation. Here totally we have 4 elements. This is the top of the element. 4, 3, 2, 1. Top of the element is 4. Bottom of the element is 1. Here in step 1 I am going to add one item called 5. Before it was top of the item was 4. Now after adding this 5, fifth element, so top will become 5. Top value is 5. So this is one example for push operation. Very simple concept. In push operation we are going to add an element. And next we have algorithms for push operation. Very important question for 5 marks. Here I am going to push an element. So we have stack, top and item which we are going to add. Here stack is the array with n elements. Here top is the pointer to the top of the element of the array which we are going to add at the top of the element, and item which we are going to insert, that is called as item. Here top is equal to n minus 1. Stack contains n number of elements. So we have to match with the size. If it is so, stack is check overflow. If top is equal to n minus 1, we have to check the condition, that is overflow. Overflow means there is no space for adding one new item. Here top is equal to 3. This condition is overflow condition because the stack is full. Full means it is overflow condition. There is no space for adding one new element. And print stack is full. Stack is full means it is overflow condition. And exit. If stack is full means the condition is overflow and exit. If top is equal to top plus 1. If stack is not full, that is 4, 2. I have 2 items here. So 0 and 1. Here top is 1. Top value is 1. Here I am going to add one new item called 3. I need to add one new item, that is 3. Here we have only 2 values, that is 0 and 1. Top is equal to 1. Here I am going to add one new element into this stack. So I can use top is equal to top plus 1. Top is equal to top plus 1 means I am going to add one extra item. So here top is equal to 1. Here I am going to add one extra item called 3. So top is equal to top plus 1. What is the top here? Top value is 1. 1 plus 1 is 2. Now top value will point to this side. So here I added one new item called 3. The top value will become 2. So we have to check the condition top is equal to top plus 1, that is increment the top. I have incremented one top value. 1 is incremented to 2. So I have used top is equal to top plus 1. One value is incremented. After that, stack of top is equal to item. So stack of top means top value is 2, that is equal to item value which I have added is 3. So stack of 2 is equal to 3. Insert the item which stack of 2 is equal to 3. Which item have inserted? That is the item 3. Have inserted the item 3. Top value is 2. So stack of 2 is equal to the item which we have inserted, that is the item 3, and return. So these conditions we have to check. Then first we have to check the condition if stack is overflow or not, stack is full or not. If it is full means print the value stack is full or overflow and exit. If it is not full means if you want to add an extra element, so you can use top is equal to top plus 1. So first check the top value and increment one more top value, that is increment the top. Check the condition stack of top is equal to item. Item means which item you are going to insert, that you need to mention here. So stack of 2 is equal to 3. 2 means top of the value, that is 2. So this is called as push operation, algorithm for push operation. Very simple concept. You have only 4 steps. In 4 steps, first you have to check the condition stack is full or not, then add the element using top is equal to top plus 1 and check the condition stack of top is equal to item and return. Very simple algorithm. And next we have pop operation. So what do you mean by pop operation? Popping means removing an element from the stack. Here I have 0 is my bottom of the stack. Base value is starts from 0 and top value is 4. Once I removed one item, top value will come to the position called 3. So here bottom of the value is 0, 1, 2, 3 and 4. Once I removed from the stack, so top will become 3. So this is called as pop operation. Popping means removing an element from the stack. So next we have algorithm for pop operation. Pop means removing an element from the stack. Pop, stack, top and item which we are going to remove. First you need to check if top is equal to null. So what do you mean by top is equal to null? You have one stack. Here there is no element to remove. Again if you want to remove one item from the stack, then we can call top is equal to null. There is no element to remove. First you need to check the condition is underflow or not. Underflow means there is no element for removing. So top is equal to null. There is no element to remove from the stack. Print stack is empty or underflow. There is no element to remove. This is called as empty stack or underflow condition. If it is so, exit. Otherwise, item is equal to stack of top. Example, here there is no element. This is underflow condition and check the second condition. Here 1, 2 and 4. 0, 1, 2. Here it is top of the stack is 2. Here I am going to remove the first element called 4. You want to remove the first element 4. So use item is equal to stack of top. So here item is equal to stack of top. Item which we are going to remove is 4 is equal to stack of top. Top value is 2. So here after using this condition, deleted item is 4. Delete this item 4 and check the condition top is equal to top minus 1. Top is equal to top minus 1 means which is the top value here? 2 minus 1 become 1. So, here top value will point to this 1. So, now top value will become 1. One item has deleted. The first item 4 has deleted, and again you want to delete the second item called 2. So, item is equal to stack of the top value is now it is 1. So, deleted item is 2, delete 2 and check the condition top is equal to top minus 1. So, top value is now 1, 1 minus 1 is equal to 0. So, top 1 is pointed to 0. Now, the top value will become 0. And again check the condition, again you want to delete the last item called 1. So, item is equal to 1, stack of top value is 0 and deleted value is 1. And check the condition top is equal to top minus 1, top value is 0 minus 1, so it is 0. Now, all the items have deleted in this stack. Check the conditions, item is equal to stack of top and copy the top element and check the condition top is equal to top minus 1, decrement the top. If you are using this top is equal to top minus 1, value will decrement from 1, 0 and minus 1. From 2, 1, 0. Value will be decremented using this top is equal to top minus 1. And after deleting the items, exit, return. So, very simple concept. First, you need to check the stack is empty or underflow. Stack is empty means there is no item for deleting. And in second step, item is equal to stack of top. Take one example problem, easily you can find the algorithms. Here I have taken one example problem for checking the condition. Item is equal to stack of top. Check the condition. So, here 0, 1, 2, index value starts from 0, 1, 2, top of the stack is 2. So, now first I will delete, I will pop the item called 4. Delete the item 4 using the step called item is equal to stack of top and use the condition top is equal to top minus 1. Top minus 1 means it is decrement the top value. Then all the value you can remove, then exit. Here you can observe before pop operation and after pop operation. Here before the pop operation the top value is 3. Before the pop operation top value is 3 and after the pop operation top value is 2 because I have deleted one item in this stack. Here I am going to delete one item called 15. I am going to pop one item. After popping one item, top will become 2. Before it was 3, one decrement value is decrement called 2. Here top value is 2 after pop operation and in before pop operation top value is 3. One item have deleted. Deleted item is 15. There is no item called 15. This is called pop operation. Pop operation means deleting an item from the stack. So, here I am going to push all the items. So, peak value becomes here and after that I am going to pop the items. All the items is pop, that is called as stack is empty. So, this is called as push and pop operation. Very simple concept. Please understand the concept. Pushing means adding an element. Popping means removing an element from the stack. So, today we learnt stacks and its operations and representation of stack. And last topic of this session is application of stacks, where we are going to use this stacks. Stack is a linear data structure. In stacks, all the elements are arranged in a sequential order. So, stacks is used for backtracking. Backtracking means is one of the concept of algorithm techniques. So, for implementing the algorithm, we are using this stacks. And also we are using in evolution expression. Expression means infix expression, postfix expression and prefix expression. And stacks are also used in expression conversion. Expression conversion means infix expression to postfix expression, postfix to prefix, infix to prefix. So, stacks are used in backtracking and expression evolution and memory management and expression conversions. So, with this we have end of this session. In my next session, I will come with a new concept called arithmetic expression. Thank you.